Laboratory that we've been using through Mission 20, you and I are talking about Mission 21. The mini lab used through Mission 20 is a tube about 7 inches long that can be divided into up to 3 chambers by clamps. So 3 small test tubes that can be combined in a prescribed way. The Mission 21 mini lab, since we changed payload services providers to from Nanorex to Rhodium, their device works the same way, but instead of a flexible tube with clamps, it's a rigid tube with butterfly valves that the astronauts turn in space. And so the idea then is that the mini lab has to support very simple experiments, very complex experiments, and the complexity of the experiment depends on the complexity of fluids and solids that make up that experiment. So I'm going to give you 2 solid examples so you can understand how this works. The first is a middle school experiment in Hillsborough County, Florida, which is not too far from where you guys are. What the middle school team said in their proposal was that astronauts are going to be going back to the moon, to Mars, to asteroids. They're going on long duration space missions, which means they're going to have to grow their own food. But we know that biology behaves differently depending on the force of gravity. And so clearly it can behave very differently in a weightless environment, because in a weightless environment, whatever you're putting there thinks that there's no gravity. And so they said, what if the germination rates of food crops are different in a weightless environment? What if the germination rates are lower? Maybe they can't even grow food in space. So in the mini lab, in the first chamber, they put dried lettuce seeds. In the second chamber, they put distilled water. And in the third chamber, they put alcohol as a fixative. So once it got to orbit, the astronauts opened the clamp and mixed the seeds with the distilled water and hydrated the seeds. And about 2 weeks later, the seeds sprouted. And at that point, they introduced the alcohol to kill and preserve the seedlings. At the same time, the flight team on the ground was doing the same experiment in the ground control mini laboratory. And when the flight experiment came down and they put them side by side, they could calculate the percentage of seeds that germinated on Earth. They could calculate the percentage of seeds that germinated in space in a weightless environment, and they could compare the germination rates. And just visual inspection allowed them to see if the root ball shape was different or the seedling itself looked different. And under high resolution microscopy, they could look at the cellular level to see if there were cell growth differences. So do you all understand how that experiment worked? Very straightforward experiment. Now, at the undergraduate level, there was a team that wanted to know if salmonella was more virulent in a microgravity environment, in a weightless environment, because that could pose a health risk to the astronauts. So in the first chamber, they put freeze-dried lyophilized salmonella. In the second chamber, they put a luria broth growth medium. And in the third chamber, they put a fixative called glutaraldehyde. And so when it got to orbit, the astronauts hydrated the salmonella, and the salmonella colony began to grow. But this team had done trials, even in support of their original proposal, that demonstrated that, at least on Earth, the salmonella colony grew so fast that they needed to terminate the experiment in just 2 days, or the colony would die in its own waste. So after it was hydrated on arrival to the International Space Station, 2 days later, the astronaut introduced the glutaraldehyde to kill and preserve the salmonella colony. The flight team was doing exactly the same thing on the ground in their ground control. And when they got the flight experiment down, this university team was able in the laboratory to measure colony size differences very accurately, and under high resolution microscopy could look for morphological differences in cell growth at the cellular level. So does everybody understand how that experiment worked? So I'm giving you 2 examples, a low-level experiment and an upper-level experiment working in the same mini lab. Anybody have any questions about mini lab operation and what we've talked about? You all good?